So it's really a sort of a looking at how well you can pay attention, okay? All right. Ready? How many?
15.
Okay, so that's what I normally get, 14, 15. I've heard 18 too. For those of you who have not seen this video, did you notice something interesting?
Yeah.
People want me.
A gorilla.
A gorilla. Did everyone see the gorilla? I swear this is the same video.
I don't remember the chest count. I do remember walking through
We're so focused on that.
Okay. So when we receive information, actually, the brain is filtering out a lot. And that's a good demonstration of that. You had a job to do, and your brain just filters out the rest. If you filtered it out, you're never going to remember what you saw, what you didn't see, right? So it's really a very powerful mechanism for the brain to use because we have so much information that we have to deal with every day. And the brain is very, very good, usually, at filtering out what's not important so that you can do what you think is important.
I just heard somebody there say that that was scary. So for whoever's thinking that's scary, if you think about it though, our memory systems are very limited. They can only deal with so much. So if we didn't have a way to filter out information, to filter out what we are completely bombarded with all of the time, we'd be puddles on the floor because we wouldn't be able to cope with everything that's coming in. So when you set what's important, filters out everything else that is extraneous, that's a real big help.
Yeah, I mean, we have to be efficient, right? So that's how we do it. And that what you allow in, the critical thing about receiving information is what you do with it when you get it, right? And how much you think about it, how much you process it. When you were listening to those words, you were thinking about how they're all related, right? You were thinking about how they are related, and what does that mean to you? So it makes it easier to remember. So it's not just the paying attention, it's also what you're thinking, how you use the information that you're getting in, that processing. And that's the key for deep linking, which we'll get to in the third session. And having those groups then made it easier because you'd already processed it to a deeper level than just, oh, here's a word, here's a word, here's a word. If they weren't related at all, it'd make it a lot harder to remember them.
Is the video available online?
The gorilla video? If you go and you Google gorilla video, usually it comes up.
It's on YouTube.
Yeah.
It's on YouTube.
Yeah. Yeah, and so the more processing you do, the easier it is to retrieve later on. And that's a really important point. Okay. Recording. So, as I said, when these networks are formed, it's actually a physiological change in the brain. Cells connect together. They form synapses and synapses are the way the cells connect to each other and talk to each other. And those synapses get more efficient. It's like creating pathways that are easier to go down again the next time. Like when you're skiing and you have a path, as opposed to trying to ski in pristine snow. It's easier when there's already a path, right? So that's the kind of connection and recordings that the brain is doing to make those pathways easier to access again. these changes actually take months to years. It's not just an instantaneous thing. And that's why they're easily interrupted, and that's why it's easy to forget things. Because these things can be, you can interfere with that, laying down those connections. And things that interfere could be things like a brain injury, if you have a car accident and you hit your head, or a concussion of some kind. That interferes with whatever synapses are forming at the time. And so often people will report that they don't remember the accident in which they hit their head. And they probably never will remember it clearly. And it's because at that time, that information could not get laid down in those networks. Illness can do it. Some medications can interfere with it. So the key here in terms of recording is brain health. And you've heard umpteen times, what kinds of lifestyle changes do you need to make to keep your body healthy? Diet, exercise, reduce stress, watch your blood pressure, watch your blood sugar. All of those things are important for brain health as well. All of those things are important for recording your memories. Enough sleep. Important. So we're not going to talk too much about those factors in this session and in other sessions, but they're really important. And they're the kind of thing, we've actually talked about having an extended sessions, and that might be one of the things that we talk about.
When I'm tired, I often forget things and it's harder to focus. Is that part of the recording too?
Right, so the question was, when I'm tired, I often forget things. And yes, that's so when you're tired, so let me get to retrieving and it'll help, okay? Because number one, if you're tired, you're not processing as efficiently. And you may not be laying, so when you don't process efficiently, those networks aren't as coalesced together, they're not as connected. But retrieving is actually a very active process. It's not just a sort of passive, information pops into your head. Sometimes it feels that way, but it actually isn't. You actually recreate the memory each time you recall it. The brain has to activate the network that was created at the time of the event for you to recall it properly. So it's very active. And that's what leads to potentially the vulnerability. Because if you recreate it in a slightly different way, because of perhaps you were grouping items and suddenly, bed got in, or what was the other one, sleep got in, then you put that into your memory. It goes in there. So each time you create it, it's a little vulnerable. But that process of recreating the memory is also another way to make it stronger. Retrieving it, each time you retrieve it, it makes it stronger. That's one of the reasons why old memories sometimes seem stronger than new ones. Because some of the old ones you've gone over again and again and again, in stories or things like that. And so they're stronger because you've retrieved them so many times, that network is much more crystallized and it's had a longer time to get together. Okay, and so each retrieval test is more recording strength, and we'll go into that one next week. We call that one Say It Again, Sam. Okay, I have good news and bad news. It's inherent in what happens when we get older. So this is one of the few graphs you're going to see of data. So this is age along this axis, and this is how good you are on a test. So here are the 20-year-olds, and here are the 80-year-olds. And you can see all the blue and the green lines, they start going down. Look at that, around 30. And they fall until you get to 80. So this was basically, this is like when you take a huge population of people and you give them these tests. That's what you see, the 20s compared to the 80s. And you see that in long-term memory. You see that in speed of processing. And you see it in what's called working memory, the kind of thing where you can hold things in your mind until you do something with it, like that phone number you're trying to remember so that you can dial it. So those things go down. So that's the bad news, but look at this. Here's the good news. We get smarter as we get older. That's wisdom. That's wisdom and knowledge. So as we get older, we accumulate more and more knowledge, and we have a way of putting it together more easily. So that's the semantic memory. And so being able to use semantic memories sticks with you for the rest of your life, assuming healthy aging. And so that is what we can call upon to help make this better. Is that semantic memory. So, factors that affect memory, particularly as we get older. So the brain changes with age, just like the rest of our bodies. And I'll show you a couple of pictures in a minute. Medications, we take more and more medications as we get older too. And sometimes that has an impact on memory. Sleeping medications are really bad for memory. Especially the short-term ones that doctors give you, the benzodiazepines, the Ativan, the anxiety drugs that say, oh, just take this and you can go to sleep because you're worrying too much. Those are really bad for memory. Stress. Probably don't have to tell you that that's bad. That's bad for everything. Poor sleep, depression and anxiety can reduce memory. Obviously the physical illnesses also are hard on memory. Those things are often associated with vascular problems, heart, your blood pressure and things like that. And so it's pipes. Pipes go to the brain as well as to the body. So heart disease, that is your arteries are clogged, probably means also they're a little clogged up here too. And then a lot of those things can accumulate into specific brain diseases like stroke or dementia, things like that. So here's a picture of the aging brain. Which one's the old brain? The one on the left. We lose mass. Just the way our muscles lose mass as we get older, so does our brain. So we have fewer cells, or we have fewer connections among the cells. And here is an MRI of the brain. This is like a slice going this way. So there's the nose and there's the back of the head. And these are ventricles or spaces with fluid that circulate the brain, which are there to bring things in and take away waste. So they help with the circulation. And it's a little hard to see in this MRI, but the cells of the brain are in these gray areas on the edges here. This is where all the cells are. And the connections, and remember, memory is all about connections and networks, are in the middle. All of this, and it's called the white matter. And there's 50% of the brain is white matter. So 50%, at least 50% of the brain is about connections. And someone estimated, I don't know how they do these things, but someone estimated that if you were to take out all the connections and lay them out around the earth, you'd go around 3 times. That's how much we have in connections. So these are what are called lacunes or white matter hyperintensity. So we get disruptions in our connections because of the vascular disease. So those factors can affect all 3 steps. So it can affect your ability to receive, it can affect your ability to record into the networks, and it can affect how easy it is to retrieve. So, the good news, not all memories are affected by normal aging. The episodic memory is probably the most vulnerable, and that's why we're all here today. The semantic memory, as I said, remains strong or gets even better. You're a storehouse of knowledge, so we're going to use that to make the episodic memory better. And the procedural memory may not change as we get older, so they say, riding a bike is you just get on again, right? It doesn't matter how long it's been. So in general, you don't forget how to ride a bike. You may need to practice a little bit when you get on it after 20 years, but you haven't lost it. You don't start back in the very beginning. But it may be harder to create a new memory. So